The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Problem 19 says a spherical bowling ball rolls without slipping along a flat wooden surface with a uniform velocity of 2 meters per second, then comes across a patch of ice with no friction between the ball and the ice. What happens to the ball? Okay, so we have our bowling ball, and it's moving at a velocity of 2 meters per second. Furthermore, it's going to be rotating at some angular velocity that we're not really concerned about. They ask what happens to the ball, and they give you a bunch of options. They tell you options in which the velocity stays the same or the velocity changes, and they give you options where it continues to roll or it stops rotating. So those are two things we need to figure out. Does the velocity stay the same, or does it change, and how does it change? Does the ball continue to roll or does it stop rolling? So what they're telling us is it's rolling along the surface and then it hits ice. Okay? So we're on ice. It says frictionless, so no force. Okay? Nothing changed. It's on ice now, so there's no friction. There's still a normal force, there's still a force of gravity, those guys are still there, but now you have no friction. Okay? So what this means is basically Newton said force is equal to the change in momentum with respect to time. If there's no force, no net force, then there's no change in momentum. So V has to stay constant. It hits ice, nothing's going to happen because it's still just moving along with no forces acting on it. An object in motion wants to stay in motion. It tends to stay in motion, excuse me. But furthermore, it will stay in motion. Now, I know the angular stuff's a little new to you guys, and it's definitely much harder to understand. Our body kind of thinks in a linear fashion, our mind rather thinks in a linear fashion. But all these laws almost always apply identically to the angular stuff. So if an object is spinning, instead of linear momentum, it has angular momentum, your L variable that you learned about. If it has angular momentum and there's no angular forces or torques or anything of that nature applied to it, such as in this situation where our frictional force is equal to 0, then there's nothing to say that it's going to stop moving or stop rolling. So our answer is that it's going to continue to roll. It's not going to stop rolling because there's no torques applied to it to change the angular momentum, which, another way of writing this, I believe this is in your book. If there's no torques applied to it and there's no change in angular momentum, it's going to continue to roll. And it's going to roll with a velocity equal to 2 meters per second. Okay? Nice conceptual question. Quick if you understand the concepts, quite difficult if you don't. But no forces means no change in momentum. No angular forces means no angular change in momentum. End of story. This is your correct answer. Choice 1 on your practice exam.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.